This is a new compact hydroelectric turbine from Natel Energy that is being used in a partnership with Symbion Power. The aim is to bring much needed electricity to remote areas, using cheap, sustainable, and fish-safe hydropower. In fact, Natel Energy say it is significantly cheaper than providing off-grid solar. From small-scale electric generators to massive dams, hydroelectric technology has been used to generate electricity for communities all around the world. The power of moving or falling water is captured by a turbine, which in turn spins a generator to produce electricity. The beauty of hydroelectric power is that it is a clean, renewable source of energy that doesn't produce any pollutants or emissions. However, if not managed correctly, large dams can be detrimental to wildlife and cause negative impacts if they break. Alternatively, turbines can be placed in rivers, giving us a practically endless cycle of clean power as the water flows through the turbine and is eventually put back up onto higher ground by the water cycle, ready to flow through again. However, river-based turbines can cause issues to local fish, meaning covers must be used to prevent them going in, which is expensive and creates additional complexity. River-based turbines must also be designed for low hydraulic heads. Hydraulic head is typically measured as a length, like meters or feet, and represents the pressure at a certain point in a fluid. Think of it this way. Imagine a glass filled with water. The pressure at the bottom of the glass is greater than at the top because of the weight of the water above it. So if we have a hydro turbine that operates with a hydraulic head of 10 meters, the pressure at the inlet would be equal to having a 10-meter column of water going into it. With these considerations in mind, Natel Energy invented their new restoration hydro turbine. The new turbine is designed to have a safe through-turbine fish passage. To achieve this, the turbine has curved blades that are thick and have a specially designed slant. Because of this, the fish are safe to swim through, and it eliminates the need for fine fish screens. Additionally, this reduces operational and development costs and increases plant efficiency. The turbine's capacities range from 30 kilowatts to 3 megawatts and can be integrated into matrix designs for larger scale developments of up to 30 megawatts. The compact turbine has demonstrated fish passage survival rates of over 99%, which is similar to that of a fish traversing a natural river section. The turbine manages this at efficiencies greater than 90%, which is extremely good for a small turbine of this size. Specifically, these are available with runner diameters measuring just 0.5 meters to 2.5 meters. As well as being compact and modular, the turbines are designed for low head applications. Based on this turbine design, Natel Energy and Symbion Power have launched a new venture called MyHydro, a pan-African power investor which plans to install Natel's new compact hydro turbine in 33 potential sites throughout the Democratic Republic of Congo. However, these will not be the first tests for Natel's turbines, as one has been extensively tested at their Monroe hydro facility, which was commissioned in September 2020 using a 300 kilowatt turbine and 5 meters of hydraulic head. Following this, they have also successfully deployed a project in Austria with a diameter of just 60 centimeters and a hydraulic head of 2 meters. This has a maximum power output of 15 kilowatts and can power homes in the local community. The location was both remote and small, making the installation of a conventional hydropower turbine too expensive and challenging. The first project in Africa will be on the Lubi River in the Kasai province, where grid electricity is not available and the population exceeds more than 4 million people. The project is scheduled to begin in 2024 and will have a maximum power output of 4.5 megawatts. The output power for a hydro turbine, when averaged over a year, is generally 25 to 75% of the maximum. So if we assume that we'll be getting 50%, it gives us 2.25 megawatts of average power. However, this will vary throughout the day and year. This means the site will produce nearly 20 gigawatt hours of electricity a year, enough for 2,000 average American homes or 40,000 average rural African homes. Though this number of homes may be even higher, as the areas chosen will likely have a lower energy demand than average. This is a significant development for the Democratic Republic of Congo, as only 10% of its over 100 million people have access to electricity, despite having about 13% of the world's hydropower potential. In the past, the Democratic Republic of Congo have relied on a few large hydro projects, like Inga 1 and 2, but these have been widely described as expensive, poorly maintained, controlled by corruption, and detrimental to both local communities and the environment. This is why MyHydro aims to deliver small, distributed hydropower projects that will offer uninterrupted power supplies 24/7 to its consumers. The aim is to be considerably cheaper than the cost of off-grid solar. Specifically, they have stated an average lifetime energy cost of just 4 to 8 cents per kilowatt hour, depending on the size and location of the turbines. This is actually similar to large-scale solar, which is roughly 4 to 6 cents per kilowatt hour, but much cheaper than smaller off-grid systems. Also, considering the hydro turbine can produce power 24/7, there'll be extra cost savings by not needing large energy storage systems. Natel Energy is also looking to improve currently operational sites, as they have worked with researchers from Oak Ridge National Laboratories, UC Berkeley, and more to show how it could help restore waterways that have been previously damaged from dams. As you're still watching, please subscribe to my channel, as I think you'll like the other videos that I make too, such as this one which talks about a rooftop wind turbine that aims to halve the price of solar panels.